Welcome to the podcast, Stories from the World of Science. Our mission is to explain science in a simple and fun form that is open to all.
Welcome to the deep dive. Today, we're going to be looking closer at the life and work of Dušan Hadži, a Slovenian chemist. He revolutionized our understanding of hydrogen bonding.
Wow.
And helped shape the landscape of scientific research in Eastern Europe.
Yeah.
We've got excerpts from a book about him. It's full of personal stories, scientific explanations, and a glimpse into what it was like to be a scientist behind the Iron Curtain.
It's a story that's both fascinating and inspiring.
Yeah.
Hadži wasn't just making groundbreaking discoveries. He was overcoming challenges, pushing boundaries.
Right.
All while nurturing a new generation of scientists.
We're going to learn about how he did it.
Okay.
Starting with his early life. His grandson, Hadži, paints a picture of young Dušan.
Yeah.
Rescuing discarded lab equipment to tinker with at home. Sounds like curiosity was in his DNA. What I find interesting is that even though he had limited access to resources, particularly growing up in post-war Yugoslavia, it didn't stop him from exploring science.
Absolutely. That resourcefulness was a constant throughout his career.
Yeah.
So he had this innate drive to experiment and figure things out, regardless of the obstacles. And it's fascinating how that early curiosity led him to a career in chemistry, specifically to the study of hydrogen bonds.
Well, speaking of hydrogen bonds,
yes,
for those of us who might need a refresher, can you explain what they are?
Of course.
And why they're so important?
Hydrogen bonds are a type of attractive force between molecules.
Okay.
They occur when a hydrogen atom, which is slightly positive, is attracted to a more electronegative atom, like oxygen or nitrogen, in another molecule. Think of it like a weak magnet.
Okay.
Now, these bonds might be weak individually, but they're everywhere in nature, and they have a huge impact.
Okay, so like they hold DNA strands together.
Exactly. And they give water its unique properties, like its high boiling point.
Right.
Which is essential for life as we know it.
Wow.
Hydrogen bonds are also crucial in protein structure and function, and they play a role in countless chemical reactions.
So hydrogen is a pretty significant area of research.
Yeah.
But it sounds like studying these bonds back in the mid-20th century, it was no easy feat.
You're absolutely right.
Yeah.
The technology available at the time was limited.
Right.
And there was a lot of mysteries surrounding the exact nature of these bonds. Specifically, scientists were grappling with the position of the proton within the hydrogen bond.
And that's where Hadži comes in with his groundbreaking research.
Yes.
He managed to establish a correlation between the length of a hydrogen bond and its vibrational frequency.
Right.
Can you explain how he did that?
Sure.
And why it was such a big deal?
He used a technique called infrared spectroscopy.
Okay.
Which essentially involves shining infrared light on a sample and measuring how much of that light is absorbed at different frequencies.
Okay.
Imagine you have a spring.
Okay.
The tighter the spring is wound, the faster it vibrates when you pluck it.
So shorter bond, higher frequency.
Precisely. The length of a hydrogen bond is a measure of how strongly the atoms are attracted to each other.
Okay.
A shorter bond means a stronger attraction. And a stronger attraction leads to a higher vibrational frequency.
Right.
Hadži was able to measure these frequencies using infrared spectroscopy.
Okay.
And correlate them to bond lengths.
Okay. That makes sense.
Yeah.
But why was this correlation so important?
It provided a new way to study and understand hydrogen bonds. It allowed scientists to predict the behavior of molecules based on the strength of their hydrogen bonds. This had implications for everything from understanding the properties of water to designing new materials and drugs.
So he wasn't just measuring things.
Right.
He was establishing a fundamental principle that had ripple effects across various fields.
Exactly.
Yeah.
And it's important to remember that this was before the widespread use of computers in scientific research.
Right.
Hadži was doing this through meticulous experimentation and data analysis, which makes his achievements even more remarkable.
It's like he was a pioneer in using this new technology to explore the unseen world of molecules.
Yeah.
And it sounds like he had a knack for pushing boundaries and challenging established ideas.
Definitely.
His work on symmetrical hydrogen bonds is a great example of that.
Yeah.
Can you tell us more about that?
Before Hadži,
the
prevailing view was that the hydrogen atom in a hydrogen bond would always be closer to one atom than the other, creating an asymmetrical bond.
Right.
Hadži, however, proposed that under certain conditions, the hydrogen atom could be located exactly in the middle, resulting in a symmetrical hydrogen bond.
So he was basically saying,
Yeah.
hey, what if we've been looking at this all wrong?
Exactly.
That must have ruffled some feathers in the scientific community.
It definitely sparked debate.
Yeah.
His ideas were met with skepticism,
Sure.
but Hadži was persistent. He used a variety of techniques to gather evidence,
Okay.
including polarized infrared light and substituting hydrogen with deuterium.
Wait, deuterium, can you break that down for us?
Deuterium is a heavier isotope of hydrogen.
Okay.
Essentially, it's hydrogen with an extra neutron. Hadži used it to subtly change the mass of the hydrogen atom in the bond,
Okay.
which in turn altered the vibrational frequency. This helped him distinguish between symmetrical and asymmetrical hydrogen bonds.
Okay, so it was like a clever trick to get more information out of his experiments.
Yeah, you could say that.
So did his findings eventually win over the skeptics?
They did. His meticulous research ultimately led to the acceptance of symmetrical hydrogen bonds. And that, in turn, had a significant impact on our understanding of molecular structure and interactions.
It's amazing how one person's dedication can change our fundamental understanding of science.
Absolutely.
Hadži was a true innovator.
Yeah.
And what's even more impressive is that he did all of this while working in post-war Yugoslavia behind the so-called Iron Curtain.
Right.
That presented a whole set of challenges that most Western scientists didn't have to face.
Absolutely.
That's a good point.
Yeah.
We know that access to resources and collaboration were limited for scientists in Eastern Europe at the time.
Right.
How did this specifically impact Hadži's work?
Well, for starters, obtaining equipment was a major hurdle.
Right.
Imagine trying to do cutting-edge research
Yeah.
when you're constantly struggling to get the tools you need. But Hadži was incredibly resourceful.
Yeah.
He managed to acquire the first infrared spectrometer in Eastern Europe,
Wow.
which was a huge accomplishment.
That must have been a game changer for him
Definitely.
and for Slovenian science in general.
Yes.
But what about collaborating with other scientists? Was that even possible?
It was difficult, but not impossible.
Yeah.
The Iron Curtain presented significant barriers to communication and travel. Attending international conferences or visiting labs in the West was often out of the question.
Right?
But Hadži found ways to work around these limitations. He corresponded with scientists from other countries. And he even managed to host some international conferences in Ljubljana.
So even though he was physically isolated to some extent,
Yeah.
he was still connected to the global scientific community.
Right.
He was determined to keep pushing the boundaries of knowledge.
Yes.
Regardless of the obstacles.
Absolutely.
And speaking of pushing boundaries,
Yes.
he wasn't content with just focusing on hydrogen bonds.
Right.
He had a much broader vision for chemistry, one that embraced collaboration across disciplines
Yeah.
and explored the connections between different areas of research.
Yeah.
It's amazing how Hadži managed to stay at the forefront of his field despite the limitations imposed by the Iron Curtain. It really speaks to his dedication and his ability to think outside the box. And it makes me curious about how he brought this innovative spirit to other areas of research.
Well, one thing that really stands out is his embrace of interdisciplinary approaches. Today, we talk a lot about the importance of breaking down silos between scientific fields, but Hadži was advocating for this decades ago.
So it wasn't enough for him to be a brilliant chemist.
Right.
He had to go and dabble in other fields, too.
It wasn't just dabbling. He understood that complex scientific questions often require insights from multiple disciplines.
Okay.
He saw the value in connecting the dots between chemistry, physics, biology, and even computer science.
Do you have an example of how he applied this interdisciplinary thinking to his research?
A great example is his work with nuclear magnetic resonance spectroscopy, or NMR. This technique is completely different from infrared spectroscopy.
Right.
But Hadži recognized its potential to provide complementary information about molecular structure and dynamics.
Can you remind us how NMR works
Sure.
and how Hadži incorporated it into his research?
NMR is based on the idea that atomic nuclei, like tiny magnets,
Okay.
can absorb and emit radio waves when placed in a strong magnetic field. By analyzing these radio waves, scientists can gain insights into the structure and behavior of molecules. Hadži used NMR to study a variety of systems, including those with hydrogen bonds,
Okay.
to gain a more complete picture of their interactions.
So it's like he was using multiple lenses to examine the same object.
Exactly.
Each one revealing different aspects of its complexity.
That's a great analogy.
Yeah.
And he didn't stop there. He also embraced computer modeling.
Okay.
which was a relatively new field at the time.
Right.
He saw its potential to simulate and predict molecular behavior, allowing scientists to test hypotheses and design experiments in a virtual environment.
It's amazing how he was always at the cutting edge, adopting new technologies and approaches to advance his research. You mentioned that computer modeling was a new field back then.
Yeah.
Was he one of the pioneers in applying it to chemistry?
He was definitely among the early adopters. He recognized that computers could be powerful tools for understanding complex molecular systems, especially those involving hydrogen bonds. And he didn't just use these tools for his own research. He advocated for their wider use in the scientific community, organizing conferences and workshops to promote computational chemistry.
So he was not only a brilliant researcher, but also a visionary leader,
Yes.
helping to shape the future of chemistry. It's clear that he was passionate about pushing his field forward and bringing others along with him.
Absolutely. And one of the areas where his forward-thinking approach really shines is in his work on biological systems.
Okay.
Remember how we talked about his interest in lipid systems for drug delivery?
Yes.
Yeah.
That was back in the early 90s, right? It seems like he was way ahead of the curve on that one. Can you tell us more about that research?
Yeah.
Why it was so significant?
Of course. Lipids are a type of fat molecule that are essential components of cell membranes.
Oh, okay.
Hadji was interested in how these lipids interact with water and other molecules, particularly in the context of drug delivery.
Right.
He recognized that if you could encapsulate a drug molecule within a lipid-based carrier, you could potentially target it to specific cells or tissues in the body.
That's incredible. It's like using tiny natural submarines to deliver medicine exactly where it's needed.
Yes.
I can see why this is such an important area of research, even today. But wasn't this a pretty big leap from studying hydrogen bonds?
It might seem that way, but Hadji saw the connections.
Okay.
He understood that hydrogen bonding plays a crucial role in how lipids interact with each other and with other molecules.
Okay.
This knowledge helped him design and optimize lipid-based drug delivery systems.
So even though he was venturing into new territory, he was still building on his fundamental understanding of chemistry.
Exactly.
He wasn't afraid to connect seemingly disparate ideas
Right.
and explore their practical applications.
Yeah, exactly. He was a true pioneer in that sense. He was always looking for ways to bridge the gap between basic research and real-world solutions.
And it wasn't just about applying his knowledge to new problems.
Yeah.
He was also deeply committed to mentoring the next generation of scientists.
Absolutely. Mentoring was a huge part of his legacy. He established research programs,
Right.
supervised countless students,
Yeah.
and constantly advocated for better integration of science into the education system. He understood that progress depends on fostering a culture of inquiry and collaboration.
It sounds like he had a profound impact on the scientific community in Slovenia and beyond.
Yeah.
But even with all his success, I imagine there were still challenges along the way.
Definitely.
Did he ever talk about those challenges?
He did. Despite his international recognition and numerous awards, he was very open about the difficulties he faced, especially working within a system that didn't always prioritize or support scientific research.
What kind of difficulties did he encounter?
Funding was a constant struggle. He often had to fight for resources to support his research and his students. The political climate could also be challenging.
Right.
Bureaucracy, limited access to international collaborations, and a general lack of understanding of the importance of scientific research were all obstacles he had to navigate.
It's inspiring to hear how he persevered despite these challenges.
Yeah.
It shows a deep commitment to his work and a belief in the power of science to make a difference.
He never lost sight of that bigger picture.
Yeah.
And he never let the challenges dampen his enthusiasm or his sense of humor. Remember that quote from his grandson about the slightly dangerous chemistry experiment they did together?
Yes. It sounds like he had a playful side and a genuine joy for sharing his love of science with others.
Absolutely. And speaking of sharing his love of science,
Yeah.
he was also a prolific writer and speaker. He published hundreds of scientific papers, wrote several books, and gave countless lectures and presentations. He was a master at communicating complex ideas in a clear and engaging way.
He was a true champion for science.
He was. And he understood that science is not just about cold, hard facts. It's about curiosity, creativity, and a willingness to challenge assumptions. It's about connecting the dots between seemingly unrelated ideas
Okay.
and using that knowledge to to solve real-world problems.
And it's about nurturing a passion for learning in others, inspiring them to push the boundaries of knowledge and make their own contributions to science.
Absolutely.
It sounds like Hadži was a truly remarkable individual who left an enduring legacy.
He was. And his story is a reminder that even in the face of adversity, a single individual can have a profound impact on the world.
It's incredible to think about the breadth of Hadži's work and the impact he had on so many different areas of science. We've talked about his pioneering research on hydrogen bonds, his embrace of interdisciplinary approaches, and his commitment to mentoring future generations of scientists. But there's one aspect of his story that we haven't touched on yet, and it's something that I find particularly fascinating.
What's that?
His connection to Rosalind Franklin, the renowned DNA researcher. I know they worked in different fields. But it turns out they had a shared starting point in their scientific journeys, Cole.
That's right. Both Hadži and Franklin began their careers by studying the structure of coal, using techniques like X-ray diffraction and infrared spectroscopy. It's a fascinating parallel.
Yeah.
Considering the very different paths their careers ultimately took.
It makes you wonder if their early work with coal somehow influenced their later discoveries. Maybe it instilled in them a certain way of thinking, a meticulous attention to detail, or a fascination with the hidden structures of nature.
It's certainly possible. And it highlights the interconnectedness of scientific fields.
Right.
How seemingly unrelated areas of research can sometimes converge in unexpected ways.
And their connection goes beyond just a shared interest in coal. One of the sources mentions that Franklin actually visited Slovenia and spent time with Hadži's family.
That's great.
They even went hiking in the Alps together.
I love that story. It humanizes these scientific giants and shows that they were more than just researchers. They were people with families, friends, and a love for exploring the world around them.
It also highlights the importance of personal connections in science. Collaboration and the sharing of ideas are essential for driving progress. And sometimes those collaborations arise from unexpected friendships and shared experiences.
Absolutely. And speaking of collaborations, I think it's worth revisiting Hadži's work on lipid systems for drug delivery.
Yes.
It's such a testament to his visionary thinking and his ability to connect fundamental chemistry to real-world applications.
Yes, we touched on it briefly, but I'd love to delve a little deeper into the specifics of his research.
Sure.
One of the sources mentions a publication from 1991 in the journal Chemistry and Physics of Lipids. It focuses on the hydration of phosphatidylcholine, which is a type of lipid found in cell membranes. Can you explain what that means and why it was significant for Hadži's work on drug delivery?
Of course. Hydration simply refers to the interaction of water molecules with other substances. In the case of phosphatidylcholine, these lipid molecules have a part that's attracted to water, hydrophilic, and a part that repels water, hydrophobic. This dual nature allows them to form bilayers, which are essentially two sheets of lipids arranged tail to tail with their water-loving heads facing outwards.
So like a water sandwich with lipid bread.
Exactly. And these bilayers are the basic building blocks of cell membranes.
Wow.
Now, Hadži was interested in how the hydration of these lipids influenced their ability to encapsulate and transport drug molecules.
So he was basically trying to figure out how to use these lipid bilayers as tiny delivery vehicles for medicine.
Precisely. He studied how different factors, like temperature and the presence of other molecules, affected the hydration of these lipids, and how that, in turn, impacted their ability to form stable structures that could carry drugs.
It's amazing to think that he was exploring these ideas back in the early 90s, long before lipid-based drug delivery systems became mainstream.
He was a true pioneer in that sense. He saw the potential of using these natural structures to improve the targeting and effectiveness of drugs. And his research laid the groundwork for many of the advancements we see in this field today.
It's a great example of how his deep understanding of fundamental chemistry allowed him to make significant contributions to a wide range of scientific disciplines.
Absolutely. And it wasn't just about the science itself. He was also a passionate advocate for the role of science in society. He believed that scientific literacy was essential for progress, and that scientists had a responsibility to communicate their work to the public.
Did he do any outreach or public engagement activities to promote science?
He did. He gave numerous public lectures, wrote articles for popular science magazines, and even appeared on television to talk about his research and the importance of investing in scientific research.
It's inspiring to hear about his commitment to sharing his knowledge and inspiring others to engage with science.
He truly believed that science had the power to solve many of the world's challenges.
Yeah.
But only if people understood its value and supported its advancement.
It's a message that's still relevant today.
Absolutely. We live in a world that's increasingly shaped by science and technology. So it's more important than ever to have a scientifically literate population.
Well, we've covered a lot of ground today.
I have.
From Hadji's early work on coal to his groundbreaking research on hydrogen bonds, his embrace of interdisciplinary approaches, his pioneering work on lipid systems for drug delivery, and his dedication to mentoring and public engagement.
Yeah.
What a remarkable life and legacy.
He was a true giant of science, a brilliant mind, a dedicated mentor, and a passionate advocate for the power of scientific inquiry.
His story is a reminder that science is more than just facts and figures.
Right.
It's about curiosity, creativity, perseverance, and a willingness to challenge the status quo. It's about connecting the dots between seemingly unrelated ideas and using that knowledge to make the world a better place.
It is.
And it's about inspiring others to follow in his footsteps, to embrace the joy of discovery, and to use their knowledge and skills to solve the challenges of our time.
Absolutely.
So as we conclude our deep dive into the life and work of Dušan Hadži, let's all take a moment to appreciate his contributions to science and to humanity.
Yeah.
And let's remember his advice to his students. Don't insult the crocodile's mother if you want to swim across the river.
Wise words indeed.
Thanks for joining us on this journey of discovery.
Yeah.
We hope you've been inspired by Hadži's story and that you'll continue to explore the fascinating world of science.
Until next time.